right, you guys. Today's lesson is an introduction to our linear functions, and so we're going to be really focusing on identifying three specific attributes of our linear function. If you are doing asynchronous, you're not going to have the opportunity to really go through this first part of the lesson, and it's a really fun lesson. But what happens is we give you a picture of a celebrity, and you guess how old they are, and then we tell you how old they actually are. And so this is just an example of a guessing that age. So the first person, we guessed the age was 37, but their actual age was 25. The second one, we guessed that their age was 39, but their actual is 35. And so what we did was we plotted on our graph. And then you'll notice on the graph, there's that line right there. That line is called the perfect guesser equation. Okay, and so what would it mean to be a perfect guesser? Well, if I was a perfect guesser, then my guess age would be the same as my actual age. So I'll give you an example. We'll do it in blue. If I guessed that their age was 10 and their actual age was 10, then I would be considered a perfect guesser. If I guessed their age was 20 and their actual age was 20, then I would still be a perfect guesser. So as we notice, the perfect guess line is going to be this guy right here. Okay. That guy right there. So that's why we have that black line right there. Now, if you look at it and you look at how I plotted my points on here, again, those are in red, okay? Those points represent what I guessed. So I want you to take a look for a second, and I want you to ask yourself, okay, am I an overguesser or an underguesser? Overguesser or underguesser? Now, you might be looking at this saying, well, Ms. Hastings, you're an underguesser because all of your little dots right here, they are under the line. So they are a underguesser. But let's take a look back. Let's go back to our equation or our table over here, and let's look at that. If I guessed that they were 37, but their actual age was 25, then I'm actually kind of overguessing here. If I guessed on the second one, their age was 39, but their actual is 35, then I'm still overguessing. So if all of our lines right here are underneath, right, am I really an underguesser? Sorry, my child. Am I really an underguesser? Actually, no. So if all of our dots right here are underneath our line, then I'm actually an overguesser. And here's why that is. You have to take into account what your x-axis is and what your y-axis is. So in this case, our x-axis is our guess age and our actual is over here. So it's really important to pay attention to your x and your y-axis and what they mean as we go through our linear functions. But again, most of my points are underneath the line, so we are an overguesser, whereas if I was an underguesser, then they would be on the top of my line. So that's just kind of just a little intro to our linear functions and give you some practice. We just gave our students some practice plotting those points, but let's take a look at that perfect guesser equation. So we have our y equals x. So let's use our function notation, which we did a long time ago, and let's use this equation and say, okay, well, our function notation, if I were to plug in that -2 right there into my equation, okay, that y equals, I would just be plugging in that -2 for x. Okay, well, if I plug in a -2, then my output is going to be a -2. Sweet. If I plug in a -1, then my output is going to be a -1. And again, you can graph this in your calculator, and it'll also show you that too. Because remember, your guess age is the same as your actual age. So if my guess age is 0 and I'm a perfect guesser, then my actual age is going to be 0. If my guess age is 1 and I'm a perfect guesser, then my actual age is also going to be 1. And same thing for this last one. If my guess age is 2, then my actual age must also be 2. So let's go ahead and let's plot that on here. So we go over -2, down 2. Boom. Over -1, down 1. Oops, sorry. We have our 0, 0, and then we have over 1, up 1, and over 2 up 2. So I'm going to go ahead and I'm going to draw this line. Now, this is awesome. Notability will like help you do this. So you just draw a straight line like that. So this is called the linear parent function. Okay, the linear parent function. And always just think about the perfect guesser. Now, if you're looking at this next piece over here, we're talking about domain and range, think about how you would crop this, like our cropping activity. Going from left to right, does it ever stop? No, it doesn't. So we're going to call this all real numbers. Okay, and then another way to represent all real numbers is using this symbol right here. Looks kind of like an R with another line in it. And so let's think about the range, which goes bottom to top. Well, since our function doesn't stop going bottom to top because it doesn't have endpoints, we're going to put this symbol right here. So the domain and range of a linear function is usually all real numbers unless it has endpoints. So now let's take a look at our attributes of our linear function. So here's one linear function. If you notice, this has a negative slope. A negative slope. So one of the attributes that you're going to have to determine is going to be the slope of our line. So if we were determining the slope of our line, we would need to find some pretty points. So I'm going to go ahead, I'm going to put this sorry, Notability just crashed. Wait for it. Come back up. Here we go. All right. So looking at this, I'm going to go ahead and look at this pretty point right here. And I'm going to look at this pretty point right here. So let's go ahead and let's find the slope. So we go rise first. So I'm going to rise up here. Sorry, my child. And then I'm going to run over here. So we go up a 1, 2, 3, 4, 5, 6. So up 6. And then we go over a 1, 2, 3. And since we went to the left, it's going to be our negative. So our slope, our first attribute that we're going to be finding is positive 6 divided by negative 3. And when you simplify that in your calculator, you end up with negative 2. Okay, that's your first attribute. Now, the next attribute we're going to be looking at is actually called our y-intercept. So just like what we were talking about when we were converting from standard form to slope-intercept form, okay, we're going to be looking for our y-intercept. So the y-intercept is a point on my graph that crosses the y-axis. Okay? Now, your y-intercept is always going to have a 0 for your x, and then whatever number is on the y-axis. So 1, 2, 3, 4, 5, 6. So y-intercept here is 6. That's the second attribute that you're going to have to find from your linear functions. All right, and then the third attribute that you're going to need to know is this guy right here. Now, if you notice, this is our x-axis. So we call this our x-intercept. Hunter, sorry, my child. I know we're not playing with that right now. Sorry, I'm trying to do this video with my child. So that x-intercept looks a little bit different than our y. So we're putting the coordinates of that. We're going to go over 3, up 0. So now look at this difference here. The 6 is the y-intercept, and this guy right here is 0. So when we find the when we find the y-intercept, the x is going to be 0. And then when we find the x-intercept, the y is going to be 0. All right, let's take a look at this one. So again, looking at our pretty points, we got here and we got here. So let's find our slope. So we rise first and then we run. Going up 1, 2, 3, so up 3, over 1, 2, 3, 4, 5, 6, 7. So we went to the right, so it's plus 7. So here's our slope. Up 7. Over 3. You cannot simplify that at all, so that's what we got. Okay, our next attribute, this guy right here, our y-intercept. Okay, sometimes your y-intercept can be labeled as b equals and whatever number it is. Other times it's going to be labeled as a point. So because it's a y-intercept, the x is 0 and the y is going to be our negative 3. Okay, and then our last attribute, our x-intercept. Now, here's what I want you to know about this. X-intercepts, they have more than one name. Okay, so again, this is over 1, 2, 3, 4, 5, 6, 7. So over 7 up 0. But there's also three other names that you're going to see this. Okay, so the first name that you're going to see is the x-intercept. Another name you're going to see it as is root. Another name you're going to see it as is solution. And then the one that you're going to see it as in the calculator is called a zero. Right, so one way that you'll be able to remember this is called ROXS, R-O-X-S. So you're like, that's not how you spell ROXS, Miss Hastings. Okay, well here's what it means. You've got your R, which stood for root. You've got your zero, which stood for this vocabulary word. Then you've got your X, which stood for x-intercept, and then your S, which stands for solution. So that's another way that you can remember all of the different vocabulary words. And yes, your STAR test will ask you all of them. Looking at our attributes. Okay, we're just going to write some different words for these. Here is your Y. Another name for that is f of x, or you might have g of x. It's always going to be your output. It'll look like this as your dependent. And then, let's see, what other some words? It might be your total. Okay, you'll see it as that word. And yeah, I think that's what we got for that. Then we've got our M, which is always going to be our slope. It's a number, also known as your rate of change. You might see it as your rise over your run, or your change in Y divided by your change in X. Our X is always going to be our input. Okay, it's our initial. It's usually your start, and your independent. Okay, and last but not least, in your slope-intercept form, you have your y-intercept. Okay, and it's always listed as 0, b. All right, so last week we decided we were trying to identify slope from an equation, and that is definitely what we're going to be doing here. However, we're going to be looking for the two other attributes. So you've got your slope, you got your y-intercept. Those are going to be easy to find, but then you're going to have your x-intercept that you're going to have to find, and that looks just a little bit different. So let's take a look at this first one. All right, finding your slope. When you find your slope, you're always going to look for the number beside your x. So that's going to be that 2 right there. So we're going to come over here and we're going to put our slope is 2. And again, you might see it as m equals, but that's not always going to be the case. So our slope here is 2. Now, if we look back at our equation up at the top, your b represents the y-intercept. So we're going to take a look at our b. Now, here's the thing. You can't just put 4 because you have to look at the whole thing, which is that -4. So the y-intercept here is -4. Okay. Now, if you get stuck with this, then what you can do is you can go to your calculator. Now, I'm going to use the TI Nspire, but you can definitely use the Desmos calculator. So I'm going to go to graphs, okay, and then we're going to plug in that equation, which is 2x minus 4. 2x minus 4. I'm going to click enter. So this has a positive slope. We already found the slope from it. And now look at this bottom piece right here, the y-intercept. Now, I showed you guys a tool the other day, and you can try it here in the Nspire app. It's called Graph Trace, or on the Desmos calculator, you can just click it. So I'm going to do Graph Trace. So trace and then Graph Trace. It's automatically going to start on the y-intercept. And notice how it says y-intercept, and if you look at the bottom of my screen, it says 0, -4. So we can come back over here and not only write it as -4, but we can also write it as 0, -4. So that's one way you're going to see it. Now the next thing that we need to do is we need to find our x-intercept. So using that graph trace tool, I'm going to go to the x-axis, going along, and boom, here is my x-intercept. So it says 0 on my calculator because that's one of the vocabulary words that you need to know, and it is 2, 0. So I'm going to come over here. You might see it written like this, x equals 2. You might see it written like this, 2, 0. Hold on, Hunter. Shh. I know, I'm sorry. You might see it written like this, f of 2 equals 0. Okay, so there's lots of different ways that you're going to see your x-intercept written, and you'll have a lot of practice with that today. All right, taking a look at the next one. Again, the easy ones to find are going to be your slope, which is right in front of the x. It's always married to your x. So that slope is -3. Then you have your y-intercept, which is next to it, and it's a +3. So we're going to put that +3 here, and let's write it as a coordinate. So 0, 3. Again, anytime you find the y-intercept, your x is going to be 0. Okay, hold on. Sorry. That's what happens when you have a 3-year-old. Okay, and then last but not least, we've got to find our x-intercept. Now, you're probably wondering to yourself, Miss Hastings, like, how do I do this without a calculator? Okay, well, let me show you how you would find your x-intercept without a calculator. So we know that in the end, whatever our answer is, whatever we're doing for our x-intercept, the y is going to have to be 0. So let's take it back to that function notation, and let's just plug it into our equation. So we have 0, okay, because I'm going to plug in a 0 right here, equals -3x plus 3. Okay, well, let's solve for x. So first thing we're going to do, we're going to subtract that 3 from both sides, so -3 over here. 0 minus 3 is -3 equals -3x. Now, to get x by itself, we're going to divide by -3 on both sides. -3 divided by -3 is a +1, and then -3 over here divided by -3 is also a +1. So our x equals 1. So what we could do, without even using our calculator, is we could take this guy and plug it in. But let me verify it for you in your calculator. So I'm going to go back to the Inspire. Add a graph. So we have -3x, and then we had our, sorry, I don't want to get it wrong, +3. Enter. Okay, let's take a look at it. Menu, trace, graph trace. All right, here's our y-intercept. If you look at the bottom, it says 0, 3. Awesome. Okay, let's go to our x-intercept. Look, it says 0, and look, it says 1, 0. So yes, this method of finding your x-intercept does work, okay? However, you are going to have your calculator, so that'll be really easy for you to use, okay? All right, let me go ahead and erase this, and we'll take a look at the next one. This next one is kind of tough because if you look at it, do you guys see an x at all? Okay, I don't know about you, but I don't see any x's. So here's what that means. Your slope is 0. Again, your slope is 0. So let's take this guy and let's look at our y-intercept. Our y-intercept is going to be all by itself right here. Okay, all by itself. So our y-intercept is going to be 7. But it might make more sense for me to show you what this looks like as a graph. So I'm going to come over here, add a graph, and then again, f of x means the same as y, so I'm just going to plug in that 7. Scoot it down a little bit. And there is our horizontal line. Notice how it doesn't have a slope at all, but it does hit our y-intercept, and I can do the trace tool as well. It does hit our y-intercept right there at 0, 7. But does it have an x-intercept? Nope, it doesn't. Because it's a horizontal line, it's crossing the y-axis, but it's not crossing the x-axis at all. So there is no x-intercept. Okay, let's take a look at the next one. X equals -5. X equals -5. So that's kind of interesting. So why don't we try and graph it first? I'm going to add a graph. Okay, I'm going to go ahead. I'm going to delete. Oh, sorry. I'm going to delete this, and I'm going to put this in like this. X equals -5. Now, if you notice, our x equals -5 is not a horizontal line. It's actually a vertical line. Okay, and if you notice, it crosses the x-axis at -5. So we would call that our x-intercept. So our x-intercept is -5, and again, you can write it as a coordinate, -5, 0. But it doesn't cross the y-axis at all, so we are not going to have a y-intercept. Okay, now if you look at this line, look at the line. What type of slope is that? Well, it's like if you're a little man climbing on the cliff, right? You're not going to be able to run it all. So you can rise as much as you want, but you're never going to be able to run. So we call this an undefined slope. So really think about that for a little bit, okay? You have your y equals a number. It has no x-intercept. And then you have x equals a number, and it has no y-intercept. So just make sure you're always graphing these in your calculator just to double check, okay? Last but not least, we have our y equals 1/2 x. So our slope is going to be the number in front of our x, which is 1/2. Our y-intercept is going to be the number after that all by itself. So it's going to be over 0, down 4. And again, we can put that in our calculator. So 1/2 x minus 4. Put an A. Minus 4. All right, just using our graph trace tool. Trace, here's our y-intercept, over 0, negative 4. And then we can come over here to this next 0, which is 8, 0. So there is our x-intercept, 8, 0. And again, you can plug this into the equation. Okay, again, this right here is 0. So we can come over here and put 0 equals 1/2 x minus 4. We'd have to add 4 to both sides. 0 plus 4 is 4. Equals 1/2 x. So some number times 1/2 is going to give you 4. So we'd have to take the reciprocal to simplify this to 1. And then what we do to one side, we'd have to do to the other. So 2 times 4 is 8. So then we would be left with this. So this is how you would do it by hand. So taking a look at these last two questions on here before you get started on your Google form, where do you find the y-intercept and how would it be written? Okay, so where you would find it would be, look at the y-axis and where the graph intercepts. Okay, and it's going to be written as 0, some number on the y-axis. Whatever number that is, okay? Then, if we're doing the opposite, where would you find the x-intercept? You're going to do the same thing, writing the same thing. So I'm going to copy it, I'm going to paste it, and then I'm just going to change some things. So instead of the y-axis, we're going to be talking about the x-axis. And instead of it being written like this, okay, it's going to be written like this, where your y is 0, and then whatever number that is right there, I'll just put it as a number. This is going to be our x-axis. So where your line crosses your x-axis is going to be your x-intercept. And that's how it's going to be written. All right, so the next thing that you're going to do is you're going to go and you're going to complete your Google form. For this assignment, there are a total of 15 questions. Please make sure that you put this stuff in your calculator and you answer your Google form correctly.